Today we are adding in function notation, and that is page 60. Okay, so when you put this in, you want your function notation on the left and then your examples that follow up on the right. So obviously go ahead and pause if you need to take time to do that. So when we are talking about function notation, we have a few extra terms that are going to jump into our list. I told you there was a lot of new terminology in here, but hopefully these are terms you've heard before. Okay, we're going to have an input value, which is going to be the same thing as the x value of a function. So now we have domain, which is x, input, the x by itself, independent, all of those are sort of representing the same thing, and the output, which is going to be the y values of a function. Okay, and everything is going to be based today on sort of plugging and chugging, input a value and get its corresponding output value. So for example, let's say we have the function rule y equals 2x minus 1. Okay, and we are then going to complete this table. So we want to fill in all of these missing values right here. Okay, so what this is saying is we want to take this input value of x, because our x is our input, and we want to plug it into our function rule and replace the x value. Okay, so right now this says 2 times x minus 1. So now instead of saying 2 times x minus 1, we're going to say 2 times 0 minus 1. Okay, then either using a calculator in your head, right? 2 times 0 is 0. 0 minus 1 is negative 1. Okay, then we'll repeat the process, and now we'll do the next one. So this one is completely irrelevant, and we're going to start over with a new one. So now instead of saying 2 times x minus 1, now we're going to say 2 times 1 minus 1. Well, 2 times 1 is 2. 2 minus 1 is 1. Okay, then we'll move on. 2 times x, so 2 times 2 minus 1. 4 minus 1 is 3. And then our last one, 2 times 3 minus 1, so 6 minus 1 is 5. Okay, so all we did was take our input value, which is our x, and substitute it, right? We're substituting it or plugging it in. So how do you substitute, I don't know, into our function to get our output value. Okay, we're taking our x value and we're substituting it into the function to find our corresponding y value. Now, that's probably something that you've seen before with those input and output values. The catch is that we're going to tweak that a little bit today. Okay, so now instead of having it written in this format, which we call a function rule, we're now going to write things in function notation. Okay, function notation just says that we are taking this new symbol right here, which we read as f of x, and we are replacing it with y. So f of x is the same thing as y. And my students are kind of like, well, why would we replace it? Well, we'll kind of see here in a minute. It's kind of like the first class of y. It's a little bit fancier, more nifty way to write things. Okay, so we would read this as f of x equals 3x plus 1. Okay, where our x is still our input value. And the way this is kind of written is a little bit confusing because we'll still evaluate, we'll still plug this in for x. But we'll evaluate what that equals to find y. It's the exact same process as what we were doing up here. So if we look at this right here, okay, and we say given the function f of x equals x minus 5, we can find f of 12. So what this says, right, it says the input value is what's sitting in those parentheses. So our f of 12 is sort of the same thing as saying x equals 12. Okay, and so we are going to substitute that 12 in for x. Okay, so now instead of saying x minus 5, we'll say 12 minus 5. Okay, so that tells us that f of 12 equals 7. Now, the reason why this is kind of the first class version is because up here, when I had my output values, unless I'm writing this in a table or as ordered pairs, there's no way for you to see your x and y sitting right next to each other. A function rule doesn't give us that option. But if we're in function notation, we can tell that this is the ordered pair 12, 7, right? It would be the same thing as x being 12 and y being 7. Or if we were to write that in a table, 12, 7. Okay, whereas on these problems up here, we sort of just got an output of something that would say something like y equals -1. Well, okay, but I need that to be written over here for me to see the x value that went with it. Okay, so once we kind of realize what this does, then it's not too difficult of a process, right? So if we want to find g of -1, we know that this is telling us that our x value is -1, and we'll just plug in -1 for x. So instead of saying 6 times x minus 2, right, we'll say 6 times -1 minus 2, which is really just -6 minus 2. So we'll say, oh, not f, g of -1 equals -8. Okay, so when x is -1, y would equal -8. Okay. The other thing that's nice about having function notation is that we can have multiple functions happening at the same time and be able to specify in between them. So if I were to write down 3 equations and just have them all say y equals, they would all be representing the exact same thing and there'd be no way for me to tell them apart. But now that I do this, right, instead of f of x, I can just change up a letter. That f is just saying a function of x, and f is what we use most commonly, okay? But we could also say g of x, or h of x, or s of t, or v of w, right? Sort of whatever variables we want to use. So now when it asks me to evaluate or to find g of 10, I know because I see this g, it's telling me to go to the g function. Okay, and so these other 2 functions are going to be irrelevant, and I want to plug in 10 for x. So instead of saying -4 times x, I'll say -4 times 10. Right, so a -40 plus 2, which will give me a -38. So g of 10 will equal -38. H of -5, right? Because this is an h, that h is telling me to go to the h function. So now these 2 are irrelevant, and I'm plugging in -5 for x here. So instead of saying 10 divided by x, I'll say 10 divided by -5. Well, that will give me -2, so h of -5 will be -2. G of -1, okay, so I have a g, so I'm back over here at my g function. Okay, so I'm plugging this in for x, so -4 times -1 plus 2. And if you say, I'm really bad at doing this as mental math, use your calculator, it's fine, just plug that into your calculator. But 2 negatives make a positive, and so our g of -1 will equal 6. Now, where we need to be most careful is going to be with our f function. Oh, this should actually be a d. That will be right on yours. Okay, because in the f function, we have this x squared. So just making sure we're really careful with how we use x squareds. That was a place that we had some problems the very first unit. So we are going to the f function, so these are relevant, and I'm plugging this 12 in. Now, here it's not a problem because my 12 is positive. So I have 12 squared plus 1. 12 squared is 144. So f of 12 is 145. But on the next one, when I plug into the f function, it's going to be a lot more important that I pay attention to my exponent of 2. Because when we plug in a -8, especially if we are using a calculator, if we want to square -8, we have to make sure that's in parentheses. Now, if you tell me, oh dear, I'm really bad at remembering when and when not to use parentheses, you can always just use parentheses. So it would not have hurt if we put that 12 in parentheses over here. Okay, because that's what allows us to know that this is a positive 64 plus 1. And so f of -8 is 65. And then we will evaluate our last one. So g of 10, I'm going to my g function. So negative 4 times 10 plus 2. We'll get negative 38. If we look at number 4. Okay, so given this function, we now want to evaluate. So now instead of being given a function rule, all we're given is a table. Ooh. Okay, so we can still do this if we understand what this means. Okay, when it says find g of 2, remember this says that our x value equals 2. So if we look over here at our table, when our x value equals 2, we know that our y value equals 5. It tells us this is the ordered pair 2, 5. So when g is 2, our output value is 5. So same thing on our next one, right? We have an input value of 0 that tells us in our table that our output value should be 1. So that same idea can then be carried over to looking at a graph. Okay, now instead of being given to us as a table, we're gonna have to find those ordered pairs from a graph. So again, when our x value is 5, so that says when I'm at x equals 5, and we know if we plot an ordered pair, it's gonna be 5 comma something. So I'm given how much I'm shifting right, I have to decide how much I'm gonna shift up or down to get to the graph. And it looks like I'm shifting up to 4. Okay, so it's saying what ordered pair has an x value of 5, says to move right 5, what is its corresponding y coordinate gonna be? 4. And then finally on our last one, if we have f of negative 2, okay, if we want to evaluate, again, where x is negative 2. So x being negative 2 says to move left 2. Making sure I'm counting and following this axis right. Sorry, this didn't print very well. So negative 2. So here, right, here's what I'm figuring out. This is our x-axis right here. Make sure we're going down right. Okay, so if I'm at negative 2, how many do I need to go to get to a graph? Well, I'm going to have to go down to get to it. So I'm going down 1, 2, 3, 4, 5. So that's at negative 5. I went down 5, so that's a negative 5.